Welcome to this tutorial regarding the formula editor. I started here a new experiment and then I go through the ribbon bar to layout and I create here a new formula page. The formula editor consists of several windows. So here is the main text editor and here you can enable and disable some more controls. So I enable here the function browser. I enable here the trace results, the scalar results, and also the help. And I arrange them a little bit different. So I get here this help line. I have here the results and here my text editor. Let's get started with the first formula. We want to get access to the actual hardware measurement data. I have here on my second page already done a measurement and I want to read out this data. So in the formula editor I write S, my signal, is equal my hardware curve, which have always the form C0 for the first device and channel A1. That's our first formula. And then I click on calculate. You see here on the trace window I've got this icon for my variable, which is also a curve. So what I can do, I can go to my page waveform, make a second area, and I can drag and drop it. And you can see that it's the same signal from the hardware curve. Let's switch back. If my data is already stored in a file, I can say S2 equal file. I press enter here and I am in my experiment folder, can open the file, and then I have to choose which curve from this file I want to extract. This is an index number, so I want to have the first index, the first curve. Then I press calculate. I have now here my second result, and as I've done this save to TPC5 with this measurement, if I remove that and I take my S2, it is actually the same coming from my data file. For accessing the second channel, I can write index 1, calculate, and you see this is actually the red curve from the hardware. Now I want to calculate the RMS value from these two curves, so I write as RMS equal the RMS function, and as you can see, you get always this automate help. You can see it here, or you see it also here in the help file, in the help window. So I take the RMS from my curve, and here I write from my S curve, and I can also say S2 RMS equal RMS S2, and then I can press on calculate. And now you see here in the result window I've got these numbers from these two calculations. So as you can see, there are two types of results. Either the result is also a curve which can be drag and dropped in the window, waveform window here, or it is a scalar function here and the result is a scalar value, and you get the result here in this window. And now you can do any arithmetic calculation here. So I can say I want to have the sum of both RMS value. So I say RMS sum equal S RMS plus S2 RMS. And now we can also test the debug function. It is possible to set here a breakpoint, and then you have to start the calculation with this debug button, and then it stops here on my breakpoint, and you can go to the next function, and you see also the results get updated. So you've got it here and here, and now our sum of these two numbers. It is also possible to sum two curves together, so I can say S3 equal S plus S2, and the result will also be a new curve which can be added here. And this is actually the sum of both channels. It is also possible to make a multiplication, for example, or removing an offset from a curve. So I can say S3 equal S multiplied by 10 plus 2. And you see I have this offset of 2 volt, and the amplitude is 10 times bigger than in the original curve. Let's have a look to the filter function. So I delete this, I only work with S. I want to get rid of this ripple here. So I take a low pass filter and I say S filtered equal low pass filter. Low pass from the curve S. There are different type of filter. So there is a Bessel filter, there's a Butterworth, Chebyshev. So we use here the Bessel filter, 4th order, 1 kHz. Calculate. So let's have a look at your this is the original, and the filter is this one. So I get rid of the ripple, but as you can see I have a time delay. So this is important to know if you use this low pass filter, as the Bessel filter will add you a time delay. So what we can do if you don't want this delay, so you can use the smooth filter. Smooth equal smooth filter on my curve, and say 50 points. Calculate it, and then you get this yellow here. This you don't have this delay on your curve, but you have filtered out the ripple. There's also a high pass filter or a band pass, or there is also a median filter. Is equal. It gives almost the same, but there you have these steps. Each trace has also some time metadata which can be read out. So each curve has a start time. So we write start time equal t begin from our curve. Calculate. And now we see here minus 002. And if you have a look, this is actually this 2 minus 2 milliseconds. 2, 4, 5 before the trigger. So the 0 point is always the trigger point. There's an end of a trace, so end time equal the end of our curve. So it's 13 milliseconds, So that's what. So this is the end of our curve. If you make multi-block measurement, then also the trigger time has a relative time since the beginning of the measurement. So if I switch here to multi-block, make 3 blocks. Now I have here my 3 blocks at 13, 32, 53 milliseconds. So if I go here and say my t equal t trigger, I get what? I get the trigger point from my first block. Because this function is always reading the curve from the left, and this is my first trigger time. If the measurement is a scope mode measurement, calculate. You see the trigger time is 0. If you look for a specific value in your curve, for example, I want to know if it is crossing 0.05 volt, I can say give me T5 equal T cross from my curve, this from the start time till the end time at 0.05. Calculate, and this gives me this 2.1 millisecond, which should be actually here this point at 0.05. Useful function are also the cursor function. So I can say, okay, I found this T5, I want to set my cursor A to this position. So I set cursor from my waveform 1 to position T5. Calculate, and now I have my cursor A exactly at this position. And now I can say, okay, I want to calculate something between 2 cursors, and I say I have my T5 end equal T5 plus 10 milliseconds. I set my second cursor, set cursor waveform 1, cursor B to T5 end. So I have set my 2 cursor here. This could be useful if you have a scalar table here, for example, which always calculates something between 2 cursors. You can automate your placement of your cursor exactly at the position you want to have it, so you don't have to place it manually. The other way around, it could be useful, for example, if you have a thing like that and you want to know what is peak between my cursors. So you place the cursor here and you can read out your cursor T1 equal get cursor waveform 1 A and T2 equal get cursor so now you have these two times T1 and T2 and you say okay, I make a slice out of that. So S short equals slice for my curve from T1 to T2, calculate, and I put it here in the second area. S short is exactly the signal between your two cursors, and then you can calculate here your peak from my S short. And of course you can repeat that. Say, place it here, press calculate, and you get your signal between your cursor and the calculated peak. So now what should we do with these calculated numbers? Of course we want to save it somewhere, and for that we can use the write line function. So I write line, and here you give a file name for your text file. So I say results. I say use the tabulator and just add a list of variables which you want to have written to this text file at each calculation. So for my example, I say, okay, I want to know T1, I want to have T2, and the peak. So if I calculate this once, this has written to this text file my 3 variables. So we can check that. We go to the single source browser in the experiment folder. I have now here my CSV file, the open file path, and I can open it with the editor, and you see these 3 values. So my T1, T2 and the peak. And if I change here the cursor position, make a calculation, and I open again my file, you see the second line here. So now we want to automate this slicing of your curve and calculating the peak and to write it in a CSV file. So, and for that we use a for loop. So I program a for loop. I have an index. The index will start at the start time until end time minus my 1 millisecond, and my step will be 1 millisecond. So for controlling that my slice is correct, I set also my cursors. Set cursor, so we can test that. I calculate here, and it was quite fast, so we try again with debug, and now you see at each step of my for loop the cursor will move 1 millisecond. Okay, that will work. So I make a slice S short equal slice for my curve, start point A plus 1 millisecond, don't need another, then my peak call peak from S short, and then we say right line results 3.csv tab stop, and we write the start time and the peak. So we can test that also with the breakpoint. We should see the slice also. So debug. So we see our slices and the peak. And if we open the file here, we open the editor, you see my peak and my start time of my slices. So far all the functions were used for post-processing, but it is also possible to use the formula editor for controlling your data acquisition device. So we remove that. So you can start the measurement by typing start recording, and then we wait until the recording is done, and then we can do our calculation. So let's filter low pass, my hardware SL for 1 kHz. If I start formula now, this will execute the start measurement, and we can see that the S filter is our filter curve. If we start again the formula, new measurement, it can also be used for continuous measurement. So I close this here. For example, I say continuous 100 kHz, and then we can say okay, start recording, delay 5 seconds, and then stop recording, and perhaps wait on end of recording for being sure that it is done, and then we calculate our filter. So let's try this. Form editor, calculate, measurement has started, 5 seconds are over, and you see here the calculated curve from this continuous mode measurement. It is also possible to trigger manually, so I turn off all the trigger here. So if I start the measurement, it is armed, but I have no new measurement. This is only the filter from the last measurement. So I stop, and then for example I can say okay, start recording, and I want to have a trigger 1 second later. Say trigger so we start, calculate, armed, triggered, and it's done. Repeat that, it is armed, triggered, and you have the new data. Sometimes it is useful to have these calculated values here in your waveform directly. So you can go to your waveform and then place here a text, and you can access any results here by typing this variable name with these brackets and this will show you your results here. You can also, of course, say this is show unit, for example. This calculation has no unit, so I have to type it here. Or you can also say big, and you have your result here. You can double click also on it, or you can change the background color to something else and say so, for indicating your results in the waveform directly. Sometimes you need your measurement data in an array or in a list or in another more complex data format, and for this you need to convert your trace to an array, for example. So you can say, okay, my array A equal conv to array of my curve, and if you calculate that, you can see here in the results, so this is not any more a trace, but this is an array. So you have all these numbers here in this list. And for example, you can access a simple element of your array by typing A2 for the second or the third element with the index 2 equal 5. And then you see in your array it is 5, and convert back to a trace. Convert to trace my array. And now, of course, as you have lost the metadata, we must specify the sampling rate. I think it was 100 kilohertz. So I have my trace T here, and now you see we have this spike here, the second sample, and actually by converting back an array to a curve, the starting point is at 0. Another more complex data type is the list. A list is almost the same like an array, but it is not determined how many elements the list has at the beginning. So we specify L equal list for declaring a new list, and then for adding elements to a list you just type L equal 1, L equal 100, L equal something. If you calculate that, you get here this list with these 3 elements. It is also possible to have mixed type of data types in your list, so I can say add string to my list, and you see here that you have this element as a string inside your list. And even a more complex data type is the dictionary. So I can write D equal dictionary, and dictionaries means that you have key value pairs in your data type element. So you can write D voltage equal 100, D current equal 2, and you see here you have your dictionary with these 2 elements, with the values 100 and 2. For reading it back, it is the same. So you say my voltage V equal, it is a string, actually voltage, and my current. And you have these two variables read back from your dictionary. Thank you for your attention. I hope you learned something about the functionality of the formula editor. More information can be found in the function description of each function in the software itself.